Picture an object that shines brighter than 250 billion suns. Now picture all of that light, packed into a space smaller than a third of a light year across. For comparison, the distance to the nearest star to us is 15 times greater than that. If this were really just a cluster of stars, we'd be looking at the most densely packed galaxy in the entire universe, right at the edge of what gravity itself allows. So, it's a black hole then? Logical. But when scientists point X-ray telescopes at this object, instruments built to catch any actively feeding black hole in the known universe, they find almost nothing. No signal, no signature. As if nature built something that shouldn't physically exist the way we're seeing it, and deliberately hid the evidence. In this video, we're going to find out what it actually is. December 2022. The James Webb Space Telescope sends back Earth's first deep images of the universe. Thousands of galaxies scattered across a black field, each one a single flash of light from an unimaginable past. Astronomers study these images for months, and among the familiar spirals and ellipticals, they start noticing something strange. Tiny, compact, bright red points. Hundreds of them. They keep showing up again and again in different parts of the sky, and with every new survey, there are more. By 2025, scientists have counted 341 of these objects. They give them a simple, almost mundane name: little red dots. The name sounds harmless. What it describes is not. These objects appear in the universe when it was only about 600 million years old, less than 5% of its current age. And roughly a billion years later, they vanish. They simply stop showing up in later images, as if they'd never existed at all. Some researchers in private conversations use a phrase that later leaks to the press. These dots break cosmology. Because according to the standard model of how the universe formed, objects this size, this bright, this old simply shouldn't exist. Nothing like them should have had time to form this early. The first explanation scientists propose is the simplest one. Maybe these are just distant, extremely dense galaxies, clusters of billions of young stars, packed so tightly by gravity that they look like a single point of light. A logical explanation, a comfortable one. The problem is, the closer scientists look at the spectrum of these points, the less it resembles the spectrum of an ordinary galaxy. The light doesn't behave the way it should. It doesn't arrive from where it should be coming from. And when a team of astronomers overlays the data and finally calculates the precise size of these objects, they're left speechless. Because what they're looking at physically cannot be a cluster of stars. Here's what scientists ran into when they finally measured these objects precisely. One of the brightest points ever found shines with the power of more than 250 billion suns. That's brighter than entire galaxies we observe much closer to us. Now, the size. All of that light comes from a region less than a third of a light year across. For comparison, the distance from our Sun to the nearest star, Proxima Centauri, is 4¼ light years, which means if you placed one of these points where our Sun is, it wouldn't even reach 1/15 of the way to the nearest star system, and yet it would shine brighter than hundreds of billions of suns combined. One researcher put it as clearly as possible: if these really were just stars, these objects would be the most densely packed galaxies in the entire universe. Not the brightest, not the largest, the densest, physically right at the edge of what gravity allows before matter starts collapsing in on itself. So it's not stars. So it's a black hole. The logical next step: if an object is this compact and this energetically powerful, then at its center, there has to be a supermassive black hole, devouring matter at an enormous rate. That would explain both the brightness and the size. But when astronomers point X-ray telescopes at these points, instruments that are supposed to detect any actively feeding black hole, they find almost nothing. No characteristic X-ray emission, no radio signal, none of what should be screaming black hole here across the observable cosmos. The object behaves at once like something that physically cannot exist, an impossibly dense cluster of stars, and like something that should be giving itself away but isn't, a growing black hole, as if nature deliberately hid the signature of the very object it created. And this is only the beginning of the strangeness, because when the spectrum of this light is finally broken down into its components, scientists find a pattern that shouldn't be there, repeating again and again, as if something inside the object is insistently trying to tell us what it is. Except what they're seeing can't be explained by any existing model. And when 3 independent teams try to find the answer, they arrive at 3 different conclusions. In the spectrum of the little red dots, astronomers find iron lines, so many that scientists jokingly call the pattern an iron forest. Such a set of lines is expected only near an extremely hot, rapidly feeding energy source. Alongside it, traces of light scattered by electrons and signs of a dense cloud of ionized gas wrapped around the object's center like a cocoon, as if something inside is deliberately hiding from direct observation, letting us see only what leaks through the shell. In January 2026, a team from the University of Copenhagen publishes a version in Nature that quickly becomes the leading one. These are young supermassive black holes surrounded by a gas cocoon so dense it absorbs almost all X-ray and radio emission, letting only the red glow of the superheated shell escape. They're called black hole stars, not stars in the usual sense, but black holes disguised as stars by their own glow. It would seem the mystery is close to solved, but not everyone agrees. Harvard astronomer Avi Loeb, together with a colleague, proposes the opposite model. Maybe these aren't black holes at all, but giant, supermassive first-generation stars of the universe. Objects that will never appear again, because the conditions for their birth existed only in the first few 100 million years after the Big Bang. A few months later, a third group of scientists proposes a third scenario: short, explosive bursts of matter consumption by black holes, so powerful they exceed the theoretical feeding rate limit. They argue that the discovered dots are only the tip of the iceberg, and that below the telescope's sensitivity threshold, many more such objects are hiding. 3 teams, 3 models, each explains part of the data, and none explains all of it. The spectrum, the brightness, the missing X-rays, the speed of disappearance, not one version matches on every point at once. Here's a fact that makes things genuinely unsettling. The little red dots aren't just rare. They seem to exist in a narrow window of time, born roughly 600 million years after the Big Bang, and nearly disappearing from observation just 1 billion years after that. As if we're looking at a flash of an entire class of objects, lasting one brief moment on the scale of cosmic history, and then going dark. In the modern universe, their counterparts, are extraordinarily rare, isolated, strange, disputed cases, as if something that happened in the early universe dozens, maybe hundreds of times, simply stopped repeating. An entire population of objects was born, existed briefly on cosmic timescales, and nearly vanished from the sky. Where did they go? One version? They burned out, exhausting the gas that fed them, and turned into ordinary, unremarkable, supermassive black holes. The kind we see at the center of most modern galaxies, including our own. Another version? Their cocoons dispersed, and whatever was hidden inside finally revealed itself as an ordinary quasar. Both versions sound plausible. Neither is confirmed. And here a question resurfaces, one that's troubled cosmologists for years, even before these dots were discovered. Supermassive black holes at the centers of galaxies, including monsters weighing billions of solar masses, have been found at such early stages of the universe's life that standard growth models simply can't explain how they gained that much mass in time. It's called the seed problem. Where did the seeds come from? The ones black holes grew from so quickly. Maybe the little red dots are the missing link. The transitional stage physicists have been searching for decades. Or maybe it's something that happened only once in the history of the cosmos and will never happen again. We're looking at the possible ancestors of nearly every black hole in the universe, including the one dormant at the center of our own galaxy right now. But the ancestors themselves are already gone. And where exactly? We don't know.